Today we're going to be talking about the zero vector, also known as the null vector, denoted by this amount right here, or this number right here, 0 with a little like arrow on it, or bolded 0. It's essentially when you add two vectors that are in opposite directions of each other. So right here I have vector A, and then my red one is negative A because it's the same magnitude, same length, but it's in the opposite direction. So you'll see when I add them together, my resulting vector is 0 vector. Right? It's also how we take care of subtracting vectors, because you'll see that subtracting is like adding the opposite vector. And so again, when I subtract two vectors, okay, I find some value in between them. I find a resulting vector. Similarly, we can take some scalar amount, let's say it's some number k, and I can multiply that k by my vector v. And so what happens is I take that value of k, it's some number, and I multiply it by v. Now, that value k also changes, or can change, the direction of my vector v. So if k is greater than 0, meaning it's a positive number, I take that positive number, multiply it by my vector to find the magnitude, and its direction would remain the same. Positive numbers, directions are the same. Conversely, when I have k being less than 0, meaning it's a negative number, I take that magnitude, and I just take that number and multiply it by my vector. But what happens is my direction changes, and it goes in the opposite direction. Because remember, negative means it's in the opposite direction. So let's look at an example right here. Okay? It says, draw a vector diagram of 3x minus 3/4 y. Okay, so first we actually want to say, okay, 3x plus negative 3/4 y. Okay, so if my x right here is, let's say, 2 centimeters, my 3x is going to be 2, 4, 6 centimeters. Okay, so that's 3x right there. And then I'm going to have 3/4 y, and it's negative. So if this is, let's say, 4 centimeters long, negative 3/4 would be 3 centimeters, and in the opposite direction. Now what you would do is you would take your protractor and figure out what that angle is, and it would go that angle but in the negative direction. So this is 3/4, negative 3/4 y. And so then my resulting vector in the tip to tail method would go right there. It's going to be right there. That's going to be my resulting vector, 3x minus 3/4 y. So that's my vector right there. Here's guided practice. It says draw a vector diagram of each expression. So a minus c plus 2b. So again, you have three values this time, or three vectors, and what you can do is, again, you can just continue to add tip to tail for every one. You might have to change the value a little bit, but you'll still get your resulting vector. Okay, example 5. An airplane is flying with an airspeed of 310 knots on a heading of 50 degrees. If a 78 knot wind is blowing from true heading of 125 degrees, determine the speed and direction of the plane relative to the ground. Okay, so first I'm just going to draw some value right here. Okay, and I use my protractor, find 50 degrees, 50 degrees, so it's going to be 50 degrees this way, right? And I draw it so that it's going to be 310 knots, right? There it is right there. It's 50 degrees. Then what's going to happen is I'm going to, from this point right here, I'm going to draw my wind at 78 knots and 125 degrees. So if this is my little beginning coordinate plane right there, 125 degrees, okay, true heading of 125 degrees is going to be over this way, and it's going to be right there in 78 knots. Okay? So then what I end up getting is my resulting vector that essentially goes tip to tail right there. Okay? So I don't know what that is right now. Okay? I don't know what that value is at this point. Okay? So if I redraw my triangle over here, okay, I know that this value right here is 310 knots. This one right here is 78 knots. Okay? I knew that this value right here was 50. I knew that this value right here was 50. Okay? And that this value right here was 125. So what can I do to figure out my values then? Well, if I want to figure out this one right here, okay? If I want to figure out that angle right there, what I'm going to do is I'm going to take my 125 degrees minus my 50 degrees, the difference between them, and I find that this is going to be an angle of 75 degrees right there. Okay? That's 75 degrees. Then what I can do is, if I know two sides, okay, if I know two sides, this side and this side, and I know the angle between them, one of my law of cosines could help me find this value right here, this resulting vector value. So what I'm going to do then is I'm going to say, okay, well, g squared is going to be equal to a squared, which was 310, plus b squared, 78, minus 2 times 310 times 78 times cosine of 75 degrees. I'll give you a second. Put this into your calculator, and you find that g squared ends up being approximately 89,667.5. So then to figure out what g is, I take the square root of both sides, and I find that g is approximately 299.4. Okay? So that's my value, my magnitude of this right here. So it's 299.4 knots. Okay? Then I need to figure out this angle right here. Now how can I figure it out? Well, if I know that this angle is across from side 78, and I know that this angle right here is across from the side that's 299.4, one of our laws helped us with that, and that was the law of sines. So we said law or sine of 75 degrees over 299.4 is equal to sine of A all over 78. So I cross multiply and I get 78 sine of 75 is equal to 299.4 sine of my missing value A. Divide both sides by 299.4. Go into my calculator. And I find that my sine of my missing side A is equal to 0.252 approximately. Now to figure out that value of A, I take the inverse sine of both sides. And so I'd end up getting A is equal to 14.6 degrees. Okay, so we did all this work. So what does it tell us? Well, it tells us that this value right here is 14.6 degrees. Okay, so to figure out, if I go back to my original picture, so to figure out this green line right here, my resulting vector between the two of them, it has a magnitude of 299.4, and it has a value right there. Well, we said if this value right here was 14.6, then this value from true north is going to be 50 minus 14.6. We'll just round it to 15. So that's 35 degrees. So my resulting vector has a speed, meaning my plane has a resulting speed of 299.4 knots at 035 degree direction. Okay? Here's an example right here, guided practice. You could try it. Same sort of idea. Add the two resulting vectors, figure out what you get. Okay? So, last example. Heather is pushing the handle of a lawnmower with a force of 450 newtons at an angle of 56 degrees with the ground. Draw the diagram to show the resolution of the force that Heather exerts in the rectangular component. So, I draw my triangle. It's going to form a right triangle. She's pushing with a force of 450 newtons right there, and at an angle of 56 degrees. So she's pushing down at 56 degrees. So there is two forces that we have to figure out. There's this one going down, we'll call that Y, and there's this one going forward with the lawnmower, we're going to call X. So to figure out what X is, right here, to figure out what X is, what we're going to do is we're going to say, all right, well, if I'm looking at angle 56, the one sitting, the side right here, is going to be its adjacent side, and we know its hypotenuse. So we're going to say the cosine of 56 degrees is going to equal some value X over 450 newtons. Okay, multiply by 450, multiply by 450, and you find that X, the magnitude of X, how hard she's pushing that way, is 252. To figure out Y, it's sort of the same thing, except for now I'm looking at the opposite side. So which one of my values was opposite? Well, that's sine. So sine of 56 degrees is equal to Y over 450. Multiply by 450, multiply by 450, and you get Y is equal to the magnitude of Y being 373 newtons. So all we've done is we said, okay, so she's pushing down at 450 newtons at 56 degrees. Okay, so if you look at the lawnmower right here, 450 newtons, 56 degrees from the ground. Okay, and what we did is we found X and we found Y components based on the right triangle form. Here's the last guided practice problem. It says a player kicks a soccer ball so that it leaves the ground with a velocity of 44 feet per second at an angle of 33 degrees with the ground. So you'll see it creates this resulting right triangle right here. And so you can use that information to figure out the components, or the horizontal component and the vertical component, same as we did before.